So here is another example on finding the nature of the roots of a quadratic equation. So it says find all possible values of m. That gives the equation m plus 2x squared minus 2mx plus 1 equal to 0 with two real roots and distinct roots. Or two real and distinct roots. So again, the idea will revolve on the discriminant b squared minus 4ac. Okay, since the problem has stated that the quadratic equation has two real roots, two real and distinct roots, we should know that if we get b squared minus 4ac, this should be greater than 0. Because that's what we said when the quadratic equation has two real roots, then the discriminant b squared minus 4ac is greater than 0. So if it says it has one real root, then that means b squared minus 4ac should be equal to 0. And if it says it has no real roots, then b squared minus 4ac should be less than 0. Okay, but in this case, we use greater than 0 because it says two real and distinct roots. So how do we move on from this idea? So creating b squared minus 4ac depends on ABC. And in this case, our ABC, so if we get the A, our A should be the expression m plus 2. Our B is negative 2m. And our C is equal to 1. Okay, by just looking at the given equation. So from here, all we have to do is to plug in the corresponding values. So we have b squared means, so let's start with our expression, b squared minus 4ac. So we know that this should be greater than 0. So b squared is negative 2m squared minus 4 times a. Our a is m plus 2. Then times c, which is 1 greater than 0. Simplifying this, will become 4m squared minus 4m minus, or let's start with distributing the 4 on the parenthesis of 4m, positive 4m. Note the minus sign is still there, so 4m and 8. So this is plus 8, and then times 1, which is basically times 1, so greater than 0. And then you have 4m squared minus 4m minus 8 is greater than 0. And then we continue by solving this inequality. So if we solve for the inequality, as you can see, we can still divide by 4. So dividing by 4 on both sides. So this would mean m squared minus m minus 2 is greater than 0. So how do we move on from here? So in solving the quadratic inequality, we need to factor m squared minus m minus 2. So we now have, from here, so we factor it. So we have two factors. So for m squared, m and m. For 2, it's just 2 and 1. And then we just apply the appropriate sign for each number. So we have m minus 2 times m plus 1 greater than 0, the new inequality. So since we're solving an inequality, we consider, since we need it to be positive, that means we are forced to make m minus 2 greater than 0, and at the same time m plus 1 is also greater than 0. Now the other case would be m minus 2 is less than 0, but at the same time, m plus 1 is also less than 0. Okay, so that's how we understand m minus 2 times m plus 1 greater than 0. It could be that both of them are positive or both of them are negative. Remember the rule on signs: negative times negative is positive, and positive times positive is also positive. Okay, because we need it to be positive, greater than 0. So the two cases are, so this negative and negative is this case, and then the positive and the positive is what you see on the left. Okay, so once you set the two cases, we can now move on to solving each case. So we have m minus 2 greater than 0 means m is greater than 2. So that's 2. And then, but you have to note that m plus 1 should also be greater than 0, or m is greater than negative 1. So if we identify the solution from this, so we have negative 1 and 2. So m greater than 2 means all the numbers bigger than 2. So those are the numbers on the right of 2. M greater than negative 1 means all the numbers on the right of negative 1. And then to find the solution to this, we need to identify the common values from each inequality, and that would be only this part of the diagram, and it means m should be greater than 2. Okay, so that's the answer for the first case. But there's also the second case, so we need to solve for that as well. So we now have m minus 2 means m is less than 2, and m plus 1 means m is less than negative 1. So we have negative 1 and 2. So the first means m less than 2, so all the numbers on the left of 2, and m less than negative 1 means all the numbers on the left of negative 1. So the common case is only on m less than negative 1. So the solution on this is that m should be less than negative 1. So combining what we have, since we have two cases, we need to combine the answer from each inequality. So m greater than 2 and m less than negative 1 means, so these are the only solution. It can only be bigger than 2 or less than negative 1. So in symbols, we write that as m is greater than 2, or just say or m is less than negative 1. So those are the only values that will make the given, or the b squared minus 4ac greater than 0. Any number that you pick in between negative 1 and 2 will not make b squared minus 4ac greater than 0. Okay, so those are the values of m that would make the equation m plus 2 x squared minus 2mx plus 1 equal to 0 to have two real roots, or two real and distinct roots. So just a quick recap on how we did it. So all you need to do is to find b squared minus 4ac, and we have to set that to greater than 0, and then just use algebra until you find the values for the m. I think a difficulty can only arise on working on the inequalities if you're not familiar with working on inequalities. Here I was able to show you how to use the factors in finding the values for m. Since we have two factors and they have to be greater than 0, we have two cases. The first factor m minus 2, greater than 0 and m plus 1 greater than 0, and the second case in which m minus 2 is less than 0 and m plus 1 is less than 0. So these cases came from the idea that negative times negative is positive and positive times positive equals positive. Okay, so I think that's just a part of the solution that can be confusing for some, so it's better to refresh yourself with on how to work on quadratic inequalities. But other than that, this should not be a difficult problem, because all you have to do is to set up b squared minus 4ac greater than 0, coming from the problem that it has two real and distinct roots. Okay, so that's it for now. I hope you do understand my explanation. Okay, so again, if you are confused with some of the parts, it's better to watch the video again and check if you will be able to understand the second time. Okay, that's it.